Hi everyone. So thanks for joining first of all to all of you. And today class is the last class. So let me tell you a few things that I will try to teach you in Python today. So we will see the from where we started, that is the ORF. So in today's class we will cover the ORF, Open Reading Frame, and we will code for this Open Reading Frame in Python. Then I will show you how to perform local and global alignment in Python. Local and global alignment in Python, guys. Okay, so these are the two things that I have in mind to try to cover today, and then let you know how Python works basically. Okay, and few of the things are there which I myself even don't know, like how to code in Python by Python. So but we'll see today how to figure those things out. Okay, so but before starting with the class, so the concept here with us is basically ORF. So let us first try to cover the fundamental, like what is the meaning of ORF, Open Reading Frame. So Disha Shah, are you there? Hello, hi Disha.
Yes, sir.
Great. So क्या आप बताएंगे like what do you understand by Open Reading Frame?
Um, so the open reading frame contains like the codons which code for a particular protein.
Okay. So what is the starting position of this ORF?
Start codon.
Great. So and what will be the end position?
Stop codon.
Or like a stop codon or end codon. Great. And in between this, there can be any codons, right?
Yeah, yeah.
Great. So one gene can have how many open reading frames?
One.
So you are saying that one gene will have only one ORF, right?
Uh, yeah. So which like a particular gene which codes for a particular protein.
Okay, so you are saying that one gene, one ORF, right?
Yeah.
Great. So okay, guys. So I'm giving an MCQ question here, and you just have to vote. Okay, that is gene codes for like a gene can have multiple ORF, and gene can have only one ORF. Okay. So all those guys who think it will have only one ORF, just type a +1 in the chat, please. All those who think a gene will have only one ORF, please put a +1 in the chat. Okay. All those who think it will have more than one ORF, please put a -1. Okay. So Disha Shah is the only one who goes with the +1, right, Disha? Great. So let me ask someone who has voted for -1. So Juhi, can you elaborate and put a light on this statement, like a gene can have multiple ORF?
यस सर
या बताइए.
एज इन क्या बताऊं मतलब सर एक जीन के अंदर कई सारे ओआरएफ हो सकते हैं ना मतलब अगर उसके अंदर स्टार्ट और स्टॉप कोडॉन्स कई सारे हैं तो मतलब उन दोनों के बीच का जो रीजन होगा बस उतना ही ओआरएफ है तो वैसा पूरा काफी हो सकता है एक जीन के अंदर.
Definitely. Good. So you know the answer. That is, a gene can have multiple ORF. And then again, there is two possibilities. There is also concept of nested ORF. Are you aware of this term, Juhi?
नो सर.
So good. So let me try to explain you. So suppose that here we have. Now just tell me one thing. So in between a ORF, so एक ORF के अंदर कितने मिथ्योनिन हो सकते हैं, स्टार्ट कोडन कितने हो सकते हैं एक लाइक एक ओआरएफ के अंदर? निधि, व्हाट डू यू थिंक? हेलो निधि, या निधि यू आर नॉट ऑडिबल. यू नॉट ऑडिबल. जूही, कैन यू ट्राई?
तो एक ही स्टार्ट कोडॉन होगा ना.
ओके, सो यू आर सेइंग कि एक ORF के अंदर एक ही स्टार्ट कोडन होगा।
यस आई
Okay.
थिंक।
अच्छा, बाय द वे स्टार्ट कोडन का मीनिंग क्या होता है? स्टार्ट कोडन कौन सा अमीनो एसिड बनाता है?
मेथियोनिन ऐसा स्टार्ट कोडॉन।
मिथियोनिन। एंड क्या ऐसा कोई रूल है कि एक ORF एक प्रोटीन के अंदर एक ही मिथियोनिन होना चाहिए?
आई थिंक
बताओ।
सो।
नो, ऐसा नहीं होता है।
ओके
ठीक है, देयर कैन बी मल्टीपल मिथियोनिन्स। ओके, सो
ओके
इट मींस दैट, बट स्टॉप कोडन नहीं होगा, बिकॉज जहां पे स्टॉप कोडन मिलेगा वहां पे वो स्टॉप हो जाएगा, राइट? सो in this particular ORF, it can contain multiple methionines, but stop codon is here. Okay, so stop codon is here. So suppose that we started with here and we got our stop codon here. Okay, and then this is one ORF. This will be delta as one ORF, and then so we started the search from here. Then start the search from here. So this will be my next searching site. So I will again start searching for finding out the methionine start codon. And suppose that we got another methionine here. So start codon, and then another stop codon is here. So this will be my another ORF. And in between this, there was nothing. So this will be known as the non-coding region. Non-coding region, because there is nothing in between this. Okay. Then, so when we are searching this pattern, that is, हमने यहाँ से start किया, यहाँ पे stop codon आया, तो ये एक ORF बन गया one. Then हम थोड़ा आगे गए, and इसके बाद, and then we started searching for the another methionine, and then we started. So what we are seeing is that we are not disturbing one ORF again. So हमने एक बार इसके अंदर गए, मैं काउंट किया और हम रुक गए. Then हम जहाँ पे स्टॉप हुआ है उसके बाद से हम आगे बढ़ रहे हैं, राइट? So this is going to be non-nested or non-overlapping ORFs. Okay, तो जहाँ पे स्टॉप हो रहा है उसके बाद से आप आगे बढ़ रहे हो. बट व्हेन सपोज दैट यहाँ पे एक मिथ्योनिन है, यहाँ पे अनदर मिथ्योनिन है, यहाँ पे एक और मिथ्योनिन है, बट स्टॉप यहीं पे है. तो पहला ORF क्या होगा? यहाँ से लेके यहाँ तक. दूसरा ORF क्या होगा? यहाँ से लेके यहाँ तक. तीसरा ORF क्या होगा? यहाँ से लेके यहाँ तक. बट क्या कोई सेंस बनेगा इस ORF को काउंट करने का, इसको और इसको? नहीं. बिकॉज व्हाई? बिकॉज ये ORF छोटे होंगे लेंथ में विद दिस. So this is not going to code for the protein we know, because the longest ORF codes for a protein. Okay, so this is going to count. So and so on. Okay, so this is the concept of ORF, that is open reading frame. So a gene can definitely have multiple ORFs, open reading frames, and that particular ORF is going to code for the protein, which is going to have the longest ORF. So okay, fine. So one gene can have multiple ORFs, and that ORF will code for the protein which has the longest length, and then the length is in terms of the number of nucleotides. Okay, guys, and this is the basically the logic for finding out ORF. That is, आप start करोगे and आप search करोगे पहला हमें AUG कहाँ मिला. जहां पे आपको AUG मिला आप उस नंबर को स्टोर कर लो. You will store this number, and then you will start. And then you will find out जब तक आपको stop codon ना मिले. So we know there are how many stop codons? So guys, anyone can tell me? So Kalash, can you tell how many stop codons are there?
So in that long ORF region you are asking.
No, total ORF, total stop codon कितने होते हैं हमारे पास?
So एक ही होते हैं एक ORF में.
एक सेकेंड. Stop codons एक होते हैं.
No, sir. There are 3 stop codons.
Yes. So there are total 3 stop codons. Okay. So stop codon ये होते हैं. उल्लू आया आया, उल्लू आया गया, उल्लू गया आया. So these are the 3 stop codons. तो आपने यहाँ से स्टार्ट किया सर्च करने, यहाँ पे स्टार्ट मिला, आपने स्टोर कर लिया नंबर. देन आपने आगे बढ़े, एंड देन you look for any of these 3 codons present. So if any of these 3 are present, so you will stop at there, and you will not take into account that as well, because आप इसको अकाउंट में नहीं लोगे स्टॉप कोडोन को, बिकॉज वो तो अमीनो एसिड बनाएगा ही नहीं, आपको प्रोटीन बनाना है, तो उसको आप कोड में अकाउंट में नहीं लोगे. सो सपोज दैट ये पोजीशन हमारी 10 है और ये पोजीशन हमारी 100 है. So आप basically 10 से लेकर के 100 लिखोगे because in Python this number is included but this is not included. So it will give you the sequence codons from 10 to 99. And then you can translate this. You can translate this and find the protein. So let me revise once again. Yeah. So let me revise this topic once again. So हमारे पास क्या एक जीन है, multiple लंबी सी जीन है, and our task is what? To find out. Our task is what? To find out the ORFs or open reading frames. Open reading frames. So how are you going to design the logic? Because right now I'm teaching you how to design the logic for this. Okay. So we know the two concepts. First of all, you need to know what is open reading frame. So we know that all the amino acids between the AUG and the any of the stop codon, this will make your open reading frame. Okay, now this is your task to find out this. So how will look at start? First of all, आप अपने जीन को डिवाइड करोगे तीन तीन के चंक्स में. कोडोन, नेक्स्ट कोडोन, कोडोन, कोडोन. So this is the task one. So find codons from the nucleotides. तो आपने न्यूक्लियोटाइड से कोडोन्स बनाओगे तीन तीन के. Then you know now कि like जहां पे हमारा पहला स्टार्ट कोडोन मिलेगा उसमें हम स्टार्ट करेंगे. So look for first start codon. Look for first start codon. So as you find out your first start codon, you will store the index. Store index of this. And then look for any of the stop codon. Look for any of stop codon. And so whichever stop codon you find out, you will write it index. Then fourth step is what? DNA start index. And then what? ये आपका पहला ORF आ जाएगा. ORF. Then you need to move on. Like आगे. So now your start will be what? Your start have to search from end plus 1. ये अगर आपका end position हुआ है, suppose that ये आपका end हुआ है यहाँ पे, जहाँ पे आपको end को stop codon मिल रहा है. अब आप अपने search इसके बाद से start करोगे, right? So you'll start looking for the searching the start index from one position after this. So start is equal to end plus 1. And then as the sequence will end, you will stop the process. So now I will show you. So this is how, this is basically, this is known as the basically the methodology. And this is thoda or programmatically, if I will write, then it will become the pseudocode for this. So this is how the pseudocodes are to be formed, and you need to know the domain field understanding of particular subject in order to write the pseudocodes. So if any of you guys have not been able to understand this concept, please ask me. Yeah. So Julie, is this much concept clear?
So can you explain the fourth point?
So अब थोड़ा सोच के देखो कि आपका जो start ORF क्या है, start position और end position के बीच का, am I right?
Yes, sir.
So आपने start में अपनी जहाँ पे start कोडन आपका start हो रहा है उसकी indexing है, और stop कोडन जहाँ पे end हो रहा है उसका index है आपके पास. उनके बीच का सारे उठा लोगे indexing से DNA को, और DNA क्या आपका कोडन से. It will give you one ORF.
Yeah.
Then you need to look for another ORF. So what you will do? Now you need to start your search once again. But क्या आप अपना search दोबारा beginning से start करोगे बताओ?
No. After the stop codon.
After the stop codon. So what you will do? You will do a start equal to end plus 1. So now you are start searching for the one position after the end codon.
Okay. Understood.
Got it? So this is the concept. Yeah. Yeah, guys, is this clear to all of you?
Yes, sir.
Great. So now I am going to show you the code for this. Yeah. So let me know if the screen is visible. So is the screen visible, guys? Or not?
Yes, sir.
Good. Now see. So here what I'm doing basically is that I'm calling all the required packages first. It will take a little bit time. So let it be. Yeah. So yes, after reading this, I need to mount my drive. I mounted my. I will tell you what I'm doing basically. Okay. So give me just a minute. Like, don't focus on this formula what I'm doing. Okay, so I will show you all these things, and I will teach you what I'm doing also. But just give me a few minutes. Yeah. Yeah. See. So let me tell you what I've done here first of all. Okay. So I've done nothing but simply I called like I downloaded a FASTA file. I downloaded a FASTA file like genome sequence file, and I'm reading that file here. Okay, and you can see that इस फाइल को रीड करने के लिए मैंने कितनी कॉम्प्लेक्स फॉर्मूले बना रखी हैं, जबकि बायोपाइथन में इट विल डन इन वन सिंगल लाइन. ओके, सो आई विल शो यू यूजिंग बायोपाइथन एज वेल, बट अभी के लिए आप छोड़ दो, तो हमारा मेन टास्क है अभी ओआरएफ कवर करना, ना कि फाइल रीडिंग. ओके, so just try to understand here. So this is our genome sequence file. So now I can read the length of this. Now see, so this is the length of the genome sequence file. That is 1, 10, 100, 1000, 10,000, lakh, 10 lakh, 46 lakh base pairs. Okay. So for the sake of understanding, let me show only the first 1000 base pairs. Yeah. This is how our sequence file is looking. Now our task is to find out the ORF from this particular sequence file. So, okay. So now I will start making you guys interact with me so that, and हम इस पे सीखेंगे सारा काम. A equal to नहीं. A. So, great. Now see, so what I'm doing basically. चलो स्टार्ट फटाफट. अब चीजों को ज्यादा कॉम्प्लेक्स किए बिना एकदम सिंपल तरीके से हम काम स्टार्ट करेंगे. ठीक है. सो ओके, सो लेट मी आस्क जूही हियर. सो जूही, आप बताओ सबसे पहला काम क्या होगा हमारा इसमें. हमें यहाँ से ओआरएफ निकालना. सबसे पहला टास्क क्या है हमारा.
Find codon for nucleotide.
So find codons, right? So I will call the function here first. Yeah. So see what I'm doing here basically is that. So I have designed a function here. So but before this function, using this function, I will teach you how this function is working. Okay, so that you will have an idea. So we now know that our DNA is looking something like this. Now we have to divide the DNA into the strings of chunks of 3. So I taught you this thing in the first class as well, I remember. Okay. So what I'll do, I will just enter to the length of the sequence. And I will begin from 0 and go till there. And with -2, comma 3. And then DNA I is to I plus 3. Now see what I get. Now see. So these are the codons that I'm getting. These are the codons that I'm getting here, guys. So I've done nothing but simply I just generated the numbers which are possible to give me this particular X again, so that you guys could also practice with me here. I pasted this particular small structure sequence there in the chat. Okay. Then I'm going to paste each and every function which I'm using. Okay, guys. So try to do hands-on with me as well. Okay, great. So yeah. So see. So what I'm doing basically is that मैं सबसे पहले अपने जितनी लेंथ है इसकी वो फाइंड आउट कर रहा हूँ लेंथ. एंड वी नो कि जब एंड पे लाइक एक कोडोन में 3 पोजीशन होती है, सो इसलिए मैंने यहाँ पे 3 कर दिया कि वी नीड टू लाइक जैसे हमारा ए जी सी कवर हो गया, सो वी विल स्टार्ट फ्रॉम टी देन एंड देन ये टी कवर हो जाएगा, देन वी विल स्टार्ट फ्रॉम टी. सो दैट्स व्हाई वी नीड टू मूव एट अ गैप ऑफ 3. देन in Python index you start from 0, that's why we are starting from 0. and end पे जब हम पहुंचेंगे, so basically यहाँ पे क्या होगा कि like suppose that when you reach here this t, so it need 3 more positions. So this t 1 2 and a core which is not there, so it will throw you error. So what we do basically is that we subtract -2 from the entire length. So -2 जब हमने किया है हम a पे आ गए, तो जब ये a पे आएगा so a plus 3, so a 1 2 3, इसके बाद हमने जनरेट ही नहीं किया नंबर. So that's why we cover all the sequences, and that's why like whenever you need to generate or divide any particular given sequence into chunks of k-mers, so you'll always give the formula here minus length of k-mer minus 1 comma length of k-mer. Suppose that we need to like, let me show you, I want to do this in a chunks of 5 k-mer. So what I'll do, 5 plus 1, it will be, sorry, it will be what? 5 minus 4. And why this you now know. Okay, and I will do 5. See. So now you can see that I have generated a k-mers of 5 k-mers of length 5. Okay, guys. If you want to play with this, you want to generate a k-mer of 10, you can do that as well. See, so you can generate. Is this much clear to all of you guys or not? I should.
Yes, sir.
Good, yeah. Okay. So now what is our task? We should like, I taught you like this formula can be called as a k-mer also. Okay. So now what is my task? I would like to convert this function from like task into a function. So let me first copy this for you guys. Oh, sorry. Okay. Now I'm going to put this into a function. Now see. So see, I have what I've written, codon underscore converter sequence comma k. So k is going to the length of the k-mer that I will select. I pasted the code. Now see what I'm doing. So for this, I first in the beginning generated an empty list codons, and then I'm going to do here the same task. Oh, sorry, like I'm generating the codons only, but this is frame. मैं यहाँ पे frame use कर रहा हूँ, ठीक है? So I taught you in the first class like frame 0, frame 1, frame 2. So for that reason, I'm giving here k. Now for I in range k comma, and this we know -23 it will go, and this will generate the codons, and then I will append each of the codon into the list codons. Now see what I'm doing basically here is that suppose that I want to go get the frame number 1, so that will be what? GCT, TTT, CAT, and so on. Third codon will be CTT, and so on. Okay. So for that reason, I'm putting here K. In today's class, we'll perform everything using the frame 0. So now I have implemented this particular function. Now I will call this function here, codon underscore converter DNA, comma, K, as I told you, 0. We are working with the 0th frame. Now see, so we have generated the list of codons. We generated the list of codons. So when you will simply implement this function, codon underscore converter DNA, comma, 0, simply if you will type here 1, it will give the codon corresponding to 1, 2, 3. So 3 will be similar to 0. That's why we never go for the codon 3. Okay. So this is how you can design the code, like the codon frame, like multiple frames. The codon on the multiple frames. Okay. So like suppose that we are going to store this codon underscore DNA. Anyone have any doubt till here? Guys, anyone? Hello.
No
Can you pardon?
doubt, sir.
Good. Now see, now I'm going to make use of this particular function. So I'm going to tell the complete logic of this function which I'm implementing here. So I will, okay, fine. So I will try to implement each and every line of this function for you guys. Now see, so what I'm doing, I'm writing here start position equal to 0. Start position 0. I will start from 0. Okay, and then I will append all the sequences codons into a ORF. So that's why I'm generating an empty list here. Then एक शॉर्टकट होता है इसमें, मैं भूल गया. Now see guys, so I will try to interpret this function for you guys, but you have to tell me. Okay, so first line chhod do, first come with the second line. So Nidhi, would you like to tell me what I'm doing here in the second line? Nidhi, are you there? Hello. I guess Nidhi is not there. Okay, Kalash, would you like to try?
Yeah, sure, sir.
या बताओ. So इस लाइन में क्या कर रहे हैं बेसिकली, सेकंड लाइन में, इफ वाले में?
So we are commanding that if the sequence is AUG,
बट यहाँ मैंने
Then,
सीक्वेंस के बाद ब्रैकेट में लिखा है, तो वो क्या है?
sequence के बाद start लिखा है, as in
वो मीनिंग क्या है
it
इसका?
suggests that AUG is a start codon, and if AUG is there, it will create something as start codon. Yeah, it will suggest it कि AUG एक start codon.
Okay. So let me tell you what I'm doing here basically. So we have started with a start, like initialize a position called 0, start 0, and ORF is empty list. So what I'm doing here basically is that I'm just going to check first कि जो सीक्वेंस है, जो लेंथ ऑफ द जो हमारे कोडोन्स हमने बनाए हैं, उसका स्टार्टिंग पोजीशन क्या AUG है. Simple. So you're just checking if the start position is AUG or not. Simple. We are just checking true or false. हमने कुछ implement नहीं किया है. लेकिन अगर if it is true, then all this is going to be implemented. Because हमने else नहीं लिखा है. If it is true, then we will implement all these things. See. Now let me tell. And before this, we are checking one thing. We are writing it while start less than length of sequence. So let me first show you how the while function works. Suppose that I am writing here s equal to 5, s equal to 0, and I type while s less than 5, print s equal to 1. Now see what I'm doing here, guys. So I just initialized element s equal to 0, and I'm going to generate the numbers which are less than 5. Like till it is going to 5, I will print all the numbers. Like whenever we write simply like this, while this less than this, it means we are putting a condition here that till this condition is going to be satisfied, keep on doing this thing, keep on doing this thing. So इसीलिए while loop is very dangerous. Why? Because sometimes we forget to put the check bar. तो फिर वो infinite loop में चले जाता है. Okay, but while loop is very, very important. You should know this thing. Okay. So we are doing this thing here. So similarly, like suppose that I type here s is 100 and I type here s less than 120. And I'm going to add all those numbers plus 5. So see what is going to happen. See. So I started with s, which is 100. I did checking if 100 less than 120. So yes, true. Then I'm going to print s plus 5. So first started with 100. Is 100 less than 120? Yes. So add 5 to it and print it 105. Then s equal to s plus 1. Then it is saying that increase s by 1. So now my s will be 100 plus 1, which is 101. Then is 101 less than 120? Yes. So print 101 plus 5, 106. And keep on repeating this function till it will be 119. So 119 plus 5, 124 should be the last number. See? Did you guys get the concept or not?
Yes, sir.
Good. So this is basically how the while loop works. It means like till your condition is going to be satisfied, it is going to do this thing. Okay, so that is what we're doing here. So it is saying while start less than length of sequence, because हमारा जो ORF होगा, हम start position अपने length से तो exceed नहीं कर सकते हैं. Am I right or not, guys? Kalash, am I right? Good. Okay, because and therefore I'm going to put a condition that till my start position is less than the length of the sequence, that is the codons. Till then only I will work or perform this task. Okay, so that's why we have put it here while start less than length of sequence, and then it is now here the condition was checked and then it was performed. So here we are going to now check the condition that if codon start position is 0, again 0 hai, then start the process. See what the process? Then it is saying for end in range. For end in range, start is what? 0, comma length of sequence. So whatever is going to be the length of sequence, so it will generate numbers in that. Now you know this function, how it works. For I in range 0, 10, so it will generate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, for end in range, start, that is 0, comma length of sequence. Suppose that length of the sequence is 100, so it will generate number from 0 to 100, that is 0 to 99. Then, so अब हम इन 3 लाइन समझते हैं पहले. Just try to understand these 3 lines. First, I am going to check if start position less than length of sequence. Yes. Then put find, like, check the condition if the first position, the start position is AUG. If it is true, then my task will be, because if it is going to satisfy, then my start position we know, like we have found the AUG. Now my task will be to find out end position. So for that we are doing here, for end in range, start comma length of sequence, because we can't exceed this. Then we will check the condition that if sequence and end, so we are initializing the number from 0, start position AUG, और फिर जब तक आपका लेंथ चल रहा है आगे तक, ओके, सो हमने चलाया और फिर हमने चेक किया सीक्वेंस एंड, एंड क्या हमारा 0 1 2 3 4, सो सीक्वेंस position number is equal to UAA. This is the first stop codon that I'm checking, and I will put a bracket because I'm going to perform multiple if condition here. So put this in bracket. Then या तो ये या, so no need to put here a double bracket. Yeah, sequence end position is UAG. Yeah, so if either UAA or UAG or UGA, and then if it is going to satisfy, then we know कि हमें end position मिल गया. So that will be my end position, and then ORF will be what? Sequence start AUG से like end तक जहाँ पे आपका end position मिला है, and this end position will not be taken into account. That is UAA or UAG or UGA will not be taken into account. So it will just return you all the codons from the starting position to the end -1 position. And then what it is saying, now when this particular task is done, I taught you that अब हमारा जब एक बार हमारे स्टॉप कोडन मिल गया तो हमारा नेक्स्ट स्टार्ट कोडन कहां से स्टार्ट होगा? कलर्स, डू यू रिमेंबर? या कलर्स, डू यू रिमेंबर?
Yes, sir. End के बाद, sir.
Yes, end के बाद से, right? So that's why you can see here that I'm writing start equal to end plus 1. Got it? And as we are going to append this start is to end, we are going to say that break. It means the loop is going to stop at that particular point only. So जैसे में stop codon मिल गया, हम वहीं पे रुक जाएंगे. Got it? So यहाँ पर आपका जो start position implement हो रहा है, वो end के बाद से start होगा. And we know we need to repeat this task for all the positions. So start equal to start plus 1. That is, you have to tell your program that start को increase कितने से करना है. Otherwise इसे पता नहीं होगा start कितने से increase करना है. So that will be a problem for this. Okay, so this is how this particular function is going to work. Now I'm going to delete this. Yeah, so this particular function is doing that. ORF underscore founder. Now let me try to put my sequence here. ORF underscore founder, and then हमने codon किस नाम से सेव किया? Codon underscore DNA. Is empty list. Why भाई? Okay. So क्या इसमें AUG है भी कि नहीं है? एक सेकंड. Oh, great. So it is saying that AUG is not there in the list even. So कैसे मिलेगा हमें? Obvious. ठीक है, तो हम क्या करते हैं? हम इसको थोड़ा बड़ा कर देते हैं फटाफट. Now our learning task is done. So C DNA C रहने देते हैं. Codon converter. So yes. Yeah, so we have converted. And now, and by the way, yes. So yeah, so it is going to append one ORF there. Okay, so it will then start once again. Okay, start यहाँ से होगा, फिर वापस इस loop में जाएगा. It will do all this thing again and again. So okay, so let me now try. It will be a list, basically list of all the codons. ORF. So ORF. Now let me check what is the length ORFs. How many ORFs we have found out. Oh God. So it is working, but okay, somehow the function में दिक्कत है. एक सेकंड, give me a minute. एक सेकंड, yeah. Okay, so let me check what is the error. So if I'm going to write here codon underscore DNA should 10, it is working fine. Okay, so for f underscore find out, let me check once again. ORF, it is empty only, so there is some mistake. So let us debug. So let me check first till here only. So and yeah. Start is 0, ORF is this, while start is less than length of sequence. So एक काम करते हैं, एक second. Codon underscore DNA 1000 100 8 dot index AUG. Oh my God, shit, man. Guys, can anyone tell me what is the error till now? God, what is the error that I'm repeating once again and again? I forgot to do one step. Hello, Nidhi, would you like to tell me what is the error? Yeah. Nidhi, can you tell me? Hello. I guess Nidhi is having some technical. Okay, fine. She is not there. Kalash, are you there in the call?
Yes, sir.
So, बताओ error क्या है? The code is everything right, but there is some error. What is the error?
So हमने index नहीं define किया था.
वो भी सही किया हमने. अगर मैं error बताऊंगा तो आप भी हंसोगे अपने ऊपर और मेरे ऊपर भी. Tell me. Neha, would you like to try? What is the error? Anyone in the call, please try to tell what is the error.
So maybe we have
Yes.
doesn't have AUGs.
Great, because हमने गलती से T को U से रिप्लेस किया ही नहीं है. हमारे RNA में U होता है, हम DNA पे काम कर रहे हैं. So the first task was to replace T with the U. Am I right?
Yes, sir.
Good. So ये चीज देखा करो प्लीज, ठीक है यार, जो मैंने नहीं देखी. मैं सोच रहा मेरी एरर क्या है, so I will have to repeat that thing. So what I will do basically is that I will replace T with U, and this will be our new sequence. Okay. Now, if I will look at my this particular, then you see that we'll have U. See, so I have replaced my T with the U. Now it will work basically. So it was my bad luck that I forgot. Yeah. Now I will check the length of my ORF. Great. So we have found out total of 13,495 ORF. Okay, guys. Guys, interest आ रहा है कि नहीं लग रहा, boring लग रहा है? Please let me know, please. Hello.
आ रहा है सर, आ रहा है.
So can you show that
So if the
replace
things are
वाला
going
code
above
once
head, then
again?
it doesn't make any sense.
So
So yeah, please go ahead.
show that replace wala code once again.
Yeah, so let me show you. See, seek dot replace bracket जिसको replace करना है, comma जिससे replace करना है.
Okay, okay, okay. Fine. Thank you, sir.
Now let us check any one of the ORF कि हमारा कोड सही काम कर भी रहा है कि नहीं कर रहा है. Suppose the 10th. Now see, AUG is there and end position हमारा होगा नहीं because हम उसे leave कर रहे हैं, right? So see, this is the length of this. Now, guys, you tell me, because this was not a gene sequence, this was genome file. Let me tell you. So here I was working with the genome file, not the gene file. Okay. Now you tell me what is your next task. आप क्या देखना चाहोगे इस genome file से? We have found out that total there are 13,495 ORFs. तो अब आप क्या देखना चाहोगे? Being a scientist, आप क्या देखना चाहोगे इस फाइल में? बताओ please. Juhi, can you
That
try?
ORFs are coding for a protein.
Can you pardon, please? Can you pardon?
Like we would like to find out how many ORFs are coding for a protein. Like overlapping ORFs कितने हैं और
ओवरलैपिंग छोड़ दो अभी, लाइक अभी ओवरलैपिंग छोड़ दो आप. अभी खाली ये बताओ कि जैसे आपने अभी सेकंड पॉइंट बताया कि लाइक इससे प्रोटीन कितने बन रहे, दैट इज अ वैलिड क्वेश्चन.
हाँ.
इसमें कितने ऐसे ओआरएफ से जो प्रोटीन बना सकते हैं, राइट?
Yes.
तो उसके लिए हम क्या कर सकते हैं, हमें कट ऑफ लगा सकते हैं कि लाइक आपको 5 कोडोन है, 5 कोडोन का ओआरएफ है, तो उसका प्रोटीन तो बनेगा नहीं, राइट? सो यू कैन पुट अ थ्रेशोल्ड आल्सो कि लाइक मिनिमम इतने से बड़ा तो हम उस ओआरएफ को कंसीडर करेंगे. सो बट दैट इज अ गुड पॉइंट. ओके, so we'll be interested to find out the length of the longest ORF and length of the shortest, but shortest हमारे काम का होगा नहीं. So we'll be interested in the length of the longest ORF. Am I right or not?
Yes, sir.
Good. So what I can do, we need to find out the length of all the ORFs. So what I can do basically is that length I for I in ORF. See, so now this function will find out the length of all the ORFs for me. What I've written, length of I for I in ORF. So this is a comprehensive style of writing the function, or like writing the for loop. And now let me check. No, see, only one codon is there, only AUG is there. So AUG आया, फिर stop codon आ गया. ऐसे भी होंगे आपके definitely. फिर 2 आया, फिर 515, 10. अब इसका maximum find out करते हैं length. So max. देखते हैं कितनी लंबी length ORF है. Now 1538. That is a good. So we'll be interested in what? Because हमें ORF निकालना है. So we'll be interested to find out the argmax. Like what is the index of that ORF? Okay, because वो तो length था. ये हमारा उसकी इंडेक्सिंग है 5218. Just give me a minute, okay? Yeah. The length is the answer 1538. Yeah, great. So I'm pressing the right one. So what I'm doing here, I have fetched the longest ORF. So let me tell you मैंने क्या किया यहाँ पे. हमारे पास ORF लेंथ की हमने एक लिस्ट जनरेट करी यहाँ पे. Len I for I in ORFs, and then we need to find out the index of that particular ORF जिसकी मैक्सिमम लेंथ थी. उसके लिए हमने np.argmax फंक्शन यूज किया. numpy का होता है np.argmax, that is the index of the maximum value, and then हमें ORF से वो पोजीशन निकालना है. So ORF this. Now let us check कैसा दिखता है ये हमारा. Now see guys, so I have performed this task. Now अब हमें क्या करना है, इसको भी एक्सपोर्ट करना है, बिकॉज ऐसे तो हम नहीं कर सकते ना काम, तो हम क्या करेंगे, एक्सपोर्ट कर लेंगे. सो फॉर दैट आई विल डू वर्क विद ओपन longest orf.txt comma w as f dot write longest orf. हमने क्या किया, लेट मी एक्सप्लेन यू दिस थिंग हियर. Okay, not an issue. It is saying that you can write a or like string, not a ORF, not a list. That is fine. But एक चीज और, कोडोन्स तो हमने बनाए हैं, बट बायोलॉजी तो उसको कोडोन नाम की चीज होती नहीं उसके लिए, तो वो तो उसको एकदम सीक्वेंस दिखेगा. सो व्हाट वी कैन डू बेसिकली इज दैट फर्स्ट लेट मी चेक longest underscore ORF. What I'll do basically is that I will join all these together into one back sequence, into the sequence. Now see, I've got the sequence once again back. Got it. Now I will write it down. Okay, so longest ORF underscore seek. Yeah, so it has written. Now I'll have to check ये फाइल राइट होगी गई कहाँ पे. So यहाँ पे तो नहीं आई होगी, ये मेरे ड्राइव पे गई है बेसिकली फाइल. Okay, because my drive is mounted right now, so I will check the directory where it os.list dir, and then see longest underscore orf.txt. Okay, so it has been written, and then I need to check the directory where is it. Get current working directory. Content drive, my drive, IACB workshop. So let me go enter there. IACB. Yeah, so this is the file. I can just open this file and see. So this is basically the longest ORF which I've got from the genome of this particular organism. This is the bacterial genome which I've taken. Now Kalash, would you like to tell me like अब हम क्या कर सकते हैं इस फाइल का, बताओ क्या करना चाहिए इसका हमें. Kalash, am I audible? Kalash,
Hello, sir. Yeah.
So can you tell me अब हमें इस फाइल का क्या करना चाहिए. ये हमने लॉन्गेस्ट ORF निकाल लिया, अब क्या करना चाहिए, प्रोटीन बनाना चाहिए.
Yeah, protein होना चाहिए.
So in the first class, I remember I taught you modeler. That is, I taught you like I told you that by the end of this course, you'll be able to do this thing. So modeler XProsy. Start modeling. and this should return me some particular protein structure. Not by nucleic acids. एक second, क्या चाहिए इसको यहाँ पे? और एक second, let me check. Phase to target sequence or UniProt AC here. एक second, target sequence. Okay, fine. So it is saying that here it requires the protein amino acid form. Okay, so what I can do, that I can get from the XParsy translate. Also आप खुद भी कर सकते थे, but हम XParsy translate से करवा लेते हैं. XParsy translate. हम यहाँ पे गए, हमने ये डाला, C. So great. So see, in the first frame, you are getting all these as the one particular ORF only, because अगर आपका नहीं होता तो आपको यहाँ पे क्या होता, small small chunks मिलते हैं. So can you say, like, validate your answer now that yes, this is a ORF? Because बीच में एक भी stop codon नहीं. Am I right or not, guys?
Right, sir.
Yeah. But of this ORF even, जैसे हमने frame change किया, next frame पे गए, see, we started getting stop codons. Okay, guys. So they are the things. अब हम क्या करेंगे, इसको हम कॉपी कर लेंगे और हम यहाँ जाएंगे और हम यहाँ पे से डालेंगे. अब see, now it is not giving error. Now it has done something. You see, 1538 codons थे हमारे पास, 1538 आ रहे हैं. So we have done everything right. And then we will say this to start building the model. In the first class when we begin, we were not able to get a model, but this time most probably it should return us some model. Okay, guys. So this is how the journey of from the genome to the protein formation goes ahead. Okay, guys. So I have showed you how these things works, and you will perform all these things. Okay.